Hello students, welcome to another tutorial on freeform. In this tutorial, we're going to look at the traumatic brain injury question. Most students tend to have a problem with this question, but let's see if we can explain it as simple as possible. I hope you guys will appreciate that. So let's see, what are we being asked to find? Here they're saying the traumatic brain injury such as concussion results when the head undergoes a very large acceleration. Generally, an acceleration less than 800 meters per second squared, lasting for any length of time, will not cause injury, whereas an acceleration greater than 1000 meters per second, lasting for 1 millisecond, will cause injury. Suppose a small child rolls off a bed that is zero point 0.4 meters above the floor. If the floor is hardwood, the child's head is brought to rest in approximately 2.0 millimeters. If the floor is carpeted, this stopping distance is increased to about 1 centimeter. Calculate the magnitude and duration of the deceleration in both cases to determine the risk of injury. Assume the child remains horizontal during the fall to the floor. Okay, now let's see what we're being asked here. So we've got an idea of what the question is. Now the next part is to look at what we can use to actually work this question out. What is the question giving us? We see one thing. The first part is just information to us, but there is something very important that is given, the condition. The key question here is we have to determine first the magnitude and duration of the deceleration in both cases. And then after that, we are supposed to use that to determine the risk of injury. So when the injury occur, when do we expect an injury to occur? Well, there are conditions which have been given to us. What are the conditions? So let's just state the conditions here. Let's use a different color. Okay, so what are the conditions for an injury to occur? Well, that's simple. In the first part, they're saying, generally, an acceleration less than 800 meters per second squared, lasting for any length of time, will not cause an injury. So in other words, if the acceleration is less than 800 meters per second, if this is the case, it doesn't matter what the time is. Time here is not important. It doesn't matter what the time is. So regardless of what the time will be, provided the acceleration is less than 800 meters per second squared, our conclusion is very simple. If this is the case, then the conclusion is no injury occurs. Okay, so this is the case if the acceleration is less than 800 meters per second. So let's just say t, if t is equal to any. Or for OT, you can say any or for OT. Now, next up, what else? The next part they're saying, whereas an acceleration greater than 1000. So if the acceleration is greater than 1000 meters per second, lasting for 1 millisecond will cause an injury. So we're saying that if the acceleration is greater than 1000 meters per second squared, and this acceleration lasts for it to last, of course, we're saying it's equal to or greater than 1 millisecond. If this is the case, what do we expect? So lasting for 1 millisecond will cause injury. So if this is what we see, then our conclusion is that we expect an injury to occur. So these are the conditions that define whether we have an injury or we do not have an injury. Now, the question is asking us to, if we go back to the question again, they're asking us to calculate the magnitude and duration of the deceleration in both cases. Okay, so that is what we want to find. So they want us to determine that so that we can determine whether there's a risk of injury or not. Okay, so how do we proceed? Well, the first part was giving us the conditions for the injury to occur. Now let's see the details. Suppose a small child rolls off a bed that is 0.4 meters above the floor. So here, let's just picture that. We have a bed. This bed is 0.4 meters above the floor. Okay, that's 0.4 meters above the floor. Then after this, so here we have the floor. Okay, what else? The next part, they're saying, yeah, if the floor is hardwood, the child's head is brought to rest in approximately 2 millimeters. If the floor is carpeted, this stopping distance is increased to about 1.0 centimeters. Okay, so we're seeing two cases there. So we're seeing that if the floor is hardwood, what we see is that the child's head is brought to rest in about 2 millimeters. But if it's hardwood, it is brought to rest in about just a centimeter. But to see exactly what is happening there, you have to kind of understand one thing. You see, this child, regardless of the type of floor where the child hits, the thing is, the child has to cover that 0.4 meters downwards, regardless of the type of flow. So the first thing that we do here is we want to know the velocity the child will hit the floor with, because that velocity will be the same, whether we're dealing with hardwood or we're dealing with carpet. This velocity the child will hit the floor with will still be the same. So that's the first thing we want to do. We want to find the velocity the child will hit the ground with. So here, of course, since the child goes down, the child starts with an initial velocity of 0. The final velocity is what we're looking for, the velocity the child hits the floor with. Apart from that, we know this part is free fall. So we kind of are interested, or we're dealing with a situation where the acceleration is negative 9.8. So as you're seeing here, I'm taking up to be positive and down to be negative. So the displacement the child falls through is 0.4 meters. So since it is down, I'll say negative 0.4 meters. So to find the velocity here, again, I'm seeing a case where I'm not working with time. So I'm going to have v squared is equal to u squared plus 2as. So I'm looking for the final velocity, which is at the v squared. So I'm looking for this. Initial velocity is 0, so I'm looking at 2 times negative 9.8 times negative 0.4. So this becomes v is equals to the square of 2 times 9.8 times 0.4. And if we evaluate this, we get the velocity, the final velocity as 2.8 meters per second. So what we're saying is the child hits this ground or hits the floor with 2.8 meters per second. Now, here comes the two cases. The two cases here. Either the floor is made of hardwood or it is carpeted. Now, if it is hardwood, what is happening? Well, if it is hardwood, we're being told that the head of this child is brought to rest in approximately 2 millimeters. What does that mean? What it means is that when the child hits the surface, when the child hits the floor, when they hit the floor, if this was the floor, when the child just hits the floor, what we see is that the child's velocity doesn't just stop there, or the child's head doesn't just stop there, but it's like the floor curves inward, even if it is just a little bit. For hardwood, the caving is very small, just 2 millimeters. For wood, for carpet, I mean, the caving is a little bit more, and it is approximated at a centimeter. Now, this distance through which this flow caves, this is the stopping distance. This is where the deceleration we are looking for is. So we want to see what is the deceleration if the stopping distance is 2 millimeters, and what is the stopping distance if the deceleration is a full centimeter. It might be very hard for you to picture how hardwood caves, but if you think about it, it actually does. If you want, or if you just want to just be clear of what is happening, think about a trampoline or something as soft as a mattress. If you were on a mattress and then you were just, or if you placed an object on a mattress, what you expect is that the object is going to curve the mattress inwards. So if you drop this object on a mattress, it strikes the mattress with some velocity, and it then forces the mattress to curve inwards. So while the mattress is curving inwards, the object is actually coming to rest. So it is reducing, the mattress is reducing the velocity of the object you dropped on it. Eventually, after the mattress curves to some distance, the object would have come to rest completely, meaning if I take this as the initial velocity, you dropped the object with, after caving the mattress inwards completely, the velocity would have been 0. Now, what we want to find is the deceleration that occurs as the mattress is caving inwards. But here, it's not the mattress we're dealing with. The mattress would cave way more. So it's not the mattress we're dealing with. We're dealing with hardwood and a carpeted floor. But to make it easy, I'm going to draw the caving way more so that it's easy for us to observe what is happening. So let's take the first part, hardwood. So let's say this floor is made out of hardwood. So if it is hardwood, if this is the level of the floor of the hardwood, we're saying this child hits the floor surface with a velocity. Here, notice that this is my starting velocity. This is the velocity the child hits the floor with. And this velocity, it is a downward value. So this is negative 2.8 meters per second. It is a downward velocity. That's why now I'm writing to the negative. Okay. After hitting this floor, what happens? Well, the floor caves inwards to somewhere there. Okay. Now, I'm not really interested in this whole part. All I'm saying is the floor caves inward up to some point. At this point, the final velocity of the child would have been reduced all the way to 0. Here, I'm just making it this big so that it's easy for us to observe what is happening. But this is our stopping distance. And this stopping distance is actually just a very small thing, very, very small, 2 milli. From the question, this is given as 2 millimeters. Okay, yeah, that is 2 millimeters. And when you want to convert millimeters to meters, this just becomes 2 times 10 to the power negative 3 meters. Of course, I hope you guys already know how to convert these units. If you don't, you can look at my series on units and conversions. Okay, now what we want to find is the deceleration that actually causes this stop to occur, or that brings something moving at negative 2.8 meters per second to rest in that short period of time. Okay, now notice that here, I'm not talking about the acceleration being due to gravity, because this is no longer free fall. This object or the hardwood is providing some resistance. So G is no longer the only thing acting on this. So here we're literally talking about just the hardwood, the influence of the hardwood on that particular object. We want to find the acceleration that actually does change, that brings about this change. So with this in mind again, we see that in these equations, there is no use of time, neither do we want it. So we're going to use an equation that doesn't use time. So that brings us to v squared is equal to u squared plus 2as. We want to find the acceleration. So we'll make acceleration the subject of the formula here. So this becomes a is equal to v squared minus u squared over 2s. We perform our substitution. The final velocity, the child comes to rest. The initial velocity is that negative 2.8. Then we have to square it. Then after that, we're dividing this by 2. The displacement is a downward displacement. So notice that the child is moving downwards into the surface, implying that this displacement has to be negative. So I'm going to use a negative. It's a downward displacement. Okay, so I hope you see where that negative is coming. Okay, with that in mind, then I can put my negative 2 times 10 to the power negative 3 meters for displacement. Okay, so with this in mind, now we can simplify this and see what we get. So this is just acceleration is equal to negative, then you have the negative 2.8 square this divided by, so this is basically just minus 4 times 10 to the power negative 2. So the negative in that negative will go. If you work this one out, you get the acceleration as 1960 meters per second squared. The question was asking for the magnitude of the deceleration. This is the deceleration that occurs. Now you might be thinking, say, deceleration is negative acceleration. Why is this value that is positive? Why are we saying this positive value is deceleration? Well, this value is positive for one simple reason. The object was moving down, so I took its velocity to be negative 2.8 meters per second. Deceleration is just acceleration, which reduces velocity. Here, it reduces this velocity, not necessarily in terms of numbers, because to reduce this number, it means that you'll be going to higher values of negative, in the negative sense, like -3 and so on, making it bigger. But here we're reducing it by saying that by magnitude, we are bringing this to 0. So that is the reduction that occurs. So an acceleration that reduces this to 0, it has to be an acceleration that goes in the opposite direction. So this acceleration had to be positive. It couldn't be in the same direction as that 2.8. This is why this acceleration ended up as a positive value. So it is a deceleration in the sense that it is reducing our velocity, bringing it to 0. Okay. So I hope you got that part correct. Okay, so we've got the acceleration. Now, is this enough? Well, if we go back, so we've got our acceleration, 1,960 meters per second. If we come back here, do we expect an injury to occur or not? We see that that acceleration is greater than 1,000, meaning that this acceleration kind of places us here. It is not less than 800, so we can't conclude that no injury occurred, but it is greater than 1,000. But still, we cannot make a conclusion right away that an injury will occur, because for an injury to occur, there are two conditions. The acceleration has to be greater than 1,000, but the time has to also be at least a millisecond. So now we want to see, how about the time? Would the time also be greater than a millisecond, or maybe the time will be less than a millisecond? Both conditions have to be correct for us to conclude that an injury will occur. So we then move on to look at what happens in terms of time. How long does it take this? How long was this deceleration taking place? So to find time, we can use the same values, but now we even have the acceleration. So we can use v is equal to u plus at to find the time. So here time will be equal to v minus u over the acceleration. So the final velocity is 0. The initial velocity is that negative 2.8. The acceleration is this value, that 1960, which is from finding. So here, if you work out this, you quickly see that the time comes out as, if you divide this, you're going to find your time as 1.43 by 10 to the power -3 seconds. But written in milliseconds, this becomes just 1.43 milliseconds. So when you look at that value, now look at what we have. We're now seeing two things. Okay, so if we look at what we have now, we're now seeing that our acceleration was equal to 1960 meters per second squared. So we see that this was our acceleration, and our time, we've just seen that it took, in terms for it to stop, this object or the boy, this child, takes 1.43 milliseconds. So the child takes about 1.43 milliseconds. So because of that, we see that if we were to go back to our conditions, you quickly see that the acceleration is greater than 1,000. And apart from that, the time is also greater than 1 millisecond. So because the time and acceleration have both checked out, we then conclude that here an injury will occur. So yes, here we expect that an injury is going to occur. Okay, so this is our conclusion for this case. Okay, the next part now is to look at, for hardwood, what happens if the floor is made up of hardwood. So in that case, not hardwood, we're coming from hardwood. So now we want to look at if it is carpeted. So if the floor is carpeted, what happens then? Okay, well, in that case, again, we're just looking at the same thing. Notice that regardless of whether carpeted or hardwood, the velocity the child hits the floor with is still the same. So the velocity the child hits the floor with is still that negative 2.8 meters per second. So again, if we are to collect our details, the only difference here is that the stopping distance now is no longer that 2 millimeters. The stopping distance this time around is a full centimeter. And if we wrote a centimeter in meters, this is just going to give us 1 times 10 to the power 2 meters. Our acceleration is to what we're looking for. We're looking for the acceleration in this case. We know the final velocity. Since the child is coming to rest, the final velocity is going to be 0. Now we want to know the acceleration that does this. So again, we use the same equation, v squared is equal to u squared plus 2as. So we make a the subject of the formula again. We're going to have a is equal to v squared minus u squared over 2s. We perform the substitution just like we did before. We're literally doing the same things. The final velocity is 0. Initial velocity is negative 2.8. So now we have negative 2.8. And then this is divided by 2 times the stopping distance. This is now that 1 centimeter, but in meters. So we have that value. So if we perform the division now, notice that our acceleration, of course, this displacement, this is a stopping displacement, so it has to be negative as well here. Here I wrote it as a positive. Let me just include that. It's a downward displacement, so it has to be negative. Okay, so lastly, if we just perform this very quickly, we see that our acceleration this time around becomes 392 meters per second squared. So this becomes the acceleration. And if we go back to the conditions, if we went back, you guys should quickly notice one thing. The conditions said if the acceleration is less than 800, so if the acceleration is less than 800, in this case, it doesn't matter what the time is, no injury is going to occur. So even if we were to calculate the time, here our conclusion is that no injury is going to occur. Why? Because our acceleration is less than 800. So our conclusion here is that if it is carpeted, no injury. So if the floor is carpeted, no injury occurs. The reason is because the acceleration is less than 800 meters per second squared. Okay, so this is how you work out this question. Hope you guys found it helpful. If you did, leave a like. Let me know how it was for you in the comment section. Otherwise, we'll see you guys in the next tutorial. This was your tutor.